Okay, everyone, welcome to the third lecture on ROS2 for NTRX 3760. You've covered an introduction and setup. You've also covered publishers and subscribers. I hope you're caught up on all that content because we'll be building on the knowledge we gathered in those lectures, and in case of some examples, we'll be building on those examples that we did in the past two lectures. So what are we doing today? We're covering the launch system for ROS2, and we're covering ROS2 interfaces. Interfaces you've actually already seen and you've already interacted with, but you may just not have realized yet, and we're going to take a closer look today. But first, let's start with the launch system. So recall our example. This is what a typical mobile robot may look like. Let's say it's a drone, or you can be creative. You can consider this to be any robotic system that flies, because it has to fly, because if you look at the bottom left, there's a flight package. So several different packages can have different number of nodes, and in some of the nodes here we have 3 nodes. But the thing is, we can have more than 3, right? We can have 5, we can have 10. And how have we been running the nodes so far? Well, let's go back to our example from the previous lecture. I'm gonna split my terminal into 2. Gonna bring this a little bigger. So we've been running nodes through ROS2 run, your package name, and then your executable name. So to run my subscriber, it's called simple subscriber. I run it like this. So my subscriber node started, and it's trying to see if messages will come in. And to start my publisher node, I do ROS2 run, my package name, which is NTRX 3760, and my executable name is simple publisher. Okay, so my publisher node has started, and every second, I think, or whatever time this is, it's sending a message, and my subscriber is successfully receiving them. So that's how we've been running nodes. The thing is, what if we have more than 2 nodes? In our flight package at the bottom left, we have 3 nodes. What if you have a complex system where you have 10 nodes, 15 nodes? What if you have an over-designed, poorly designed system where you have 50 nodes? Are you going to start 50 terminals and do ROS2 run every time? Probably not. Even if you wanted to, even if you really bought it and you want to waste time and say, I'm going to start 50 terminals and do ROS2 run 50 times, what if you needed the nodes to start at the same time? What if it was crucial that my publisher node and my subscriber node started at the exact same time? So this is the question we ask. We've been doing ROS2 run every time. Is there a better way? I hope you've guessed it. The answer is yes, we do have a better way to do it. And it's called the launch system for ROS2. The launch system for ROS2 allows for multiple nodes in the package to be started at the same time and with their own configurations. What do I mean by configurations? So earlier, I was sending the coordinates x equals 1, y equals 2. What if I want to configure it so that when I launch it, or when I start the node, I want to send x equals 3, y equals 4 instead? So not only can we start nodes at the same time, we can also configure nodes when we start them. So how do we do this? Well, we use launch files, and the launch files are typically in the language of Python. It uses the launch library from Python, which is not ROS specific, but it does have a ROS specific extended version of launch. Is it the only way to write a launch file? No, it can also be written in XML and YAML. In fact, this is how ROS1 used to do it. ROS1 did not have Python launch files. It had, I think, XML or YAML. It's one of them, not both. I think it had one of them. And it's been a while since I've written a launch file in ROS1, so I can't remember at the top of my head, but it was one of these two. But now in ROS2, we use Python conventionally. Can you write in XML YAML? Yes, but in this course, we're going to use Python. And if you look at most open source ROS2 projects, they use Python. So please just use Python. So where do the launch files go? They're usually located in the launch directory of a package. So I'm going to bring up my terminal again. Gonna exit one of these. So my package is called NTRX 3760 in lowercase. The uppercase here is just my workspace, my entire ROS2 workspace, that is. So my package, if I list out its contents, we see that we have an include for the header files, source files for the implementation, and then we have CMake to define how a project's built, and then package for everything, the metadata related to the package, of course. Launch files are located in the launch directory of a package. So we don't have a launch directory. So what we do, well, we're gonna create one. Make directory launch. We have a launch directory now. We can go inside that directory. It's empty, of course. Does it have to be here? The answer is no. You don't have to be in. Don't know what that was. You don't have to be in the launch directory to write a launch file. But once again, it is convention. Please make everyone else's lives easier and put your launch files in the launch directory. It's empty right now, so I'm going to create a launch file. My launch file, I intend to start the publisher and the subscriber node from earlier that you just saw, so I'm going to name it pub sub launch.py. Hope that makes sense. If it doesn't, I don't know what to tell you. We have a pub sub launch.py now. As you see, I've named it with whatever I want for the name and then underscore launch.py. That is the convention. Again, do you have to name it this way? No, but it's best practice and convention, so please just do it. How do we deploy the launch file? It's empty right now. If I just created it, so if I cat it, it's empty. But let's say if it was full, how do we make use of the launch file? We do ROS2 launch your package name, and then whatever your launch file name is. So in our case, it's pub sub launch.py. Of course, nothing will happen here because, well, we haven't done anything. Don't be tempted to do this. Don't do Python 3 pub sub launch.py. Nothing will happen. Nothing good will happen, at least. So that's how we started. We'll look at how we write one in just a second. But I mentioned earlier that the Python launch library is not ROS specific, but there is a ROS specific one. And those are the two main modules that the launch system is built on. We have launch from Python, and then launch ROS, which is an extension of the launch library, but for ROS specific actions. Hope that makes sense. Let's take a look at what a launch file actually looks like. This is what it looks like. We're going to go into detail a bit later, but for now, know that this is the most basic example. This is as minimal as it gets. You can probably tell that all you need to do is define some nodes, and for nodes, you just have to define a few parameters. The two essential parameters you have to define are the package name and the executable name. Are there more parameters? Yes. Do I know them at the top of my head? No. And the documentation can be found here, of course. And if you look at most open source ROS2 projects, you'll see that there's a lot more parameters that go in. There may be 5, 6, 7 extra parameters that go inside. But for now, what I'm going to do is copy this and then paste it into my VS Code. So this is my workspace. This is where I just created the launch directory as well as the pub sub launch file. Copy, paste. My package is not called Vision, it's called NTRX3760, so I'm going to rename it as so. My executables are also not called this. They are called simple publisher and simple subscriber. That is our launch file. We've written our launch file. Congrats, give yourself a pat on the back. Now, what next? Let's take a closer look at launching. We've written a launch file. I'll show you how what its behavior is like in just a second, I promise. But one thing you need to know is that every launch file requires a generate launch description function. And that function will always return a launch description. So as far as I'm concerned, if your Python file does not have a generate launch description, it's not a launch file. If this function does not return a launch description, it's not a launch file. So naturally, the next question might be, what is a launch description? Well, a launch description is just a sequence or a series of actions to be executed. And then you may ask, what is an action in this case? An action is literally just any executable process. Anything that you can start, anything that is a task that you can start to perform some sort of computation, analysis, data gathering, that is an action, any executable. So a launch description takes a series of these actions and just executes them, right? Actions can be ROS specific or not ROS specific. But most of the time, you'll be using ROS specific actions because 99% of the time, the only thing you need is the node action, which you saw earlier, and that comes from launch_ROS. This is what I just said. The most common action will be from launch_ROS, which is just node. There'll be another action. There are plenty more actions. We'll look at one more in a bit, but for now, just know that node is what you will need just most of the time. Now, the most important part, maybe not the most important part, but the most important part that may come into play if you're writing a launch file for the first time, something you may forget is telling your CMake list about your new launch directory. Recall that ROS2 builds your C++ projects using CMake list. If your builder is not aware of a new room that you've put into the building, well, things are not going to go how you want during the building process. Similarly, with CMake, if you don't tell it that, hey, I've created a new launch directory and I've put a new launch file there, nothing's going to happen. You can co-compile it as much as you want and nothing will happen. Let's see that in action, actually. So I'm going to bring out my terminal and co-con build. Everything should be fine. Yep. I will source it. And we launch, if you recall, through ROS2 launch the package name and then pub sub launch.py. Nothing will happen because we haven't told our CMake list that, hey, there is a new directory. How do we do that? Well, let's just ching. On Foxy for some reason. We'll go to Humble just in case, but it should be the same most of the time. We're using C++. Okay, so if you because we're using C++, it says for C++ packages we need to adjust the CMake list by adding this. So it says added to the end of the launch file, at the end of the CMake list.txt, but before ament_package. Let's do exactly that. We're going back to our CMake list. Why is it so zoomed in? There we go. And we're gonna paste that right there. Now let's try it again. We're gonna co-con build. We're going to source. And then we're going to ROS2 launch. Fingers crossed, let's see what happens. Cool. Our subscriber node and my publisher node started at the exact same time. The autopilot is my publisher node, and my motion control node is my subscriber node. As you can see, it started. I'm going to stop it for a second. It started at the same time. There we go. We've written our very first launch file, and we've made sure that two of our nodes start at the same time. Let's go back to our slides. This is what we just did before. As you can see, there are many different ways to write a launch file. In front of you, there's 3 different ways, but if you look at it closely, they all kind of just do the same thing. There's always a function which is generate launch description. That function will always return a launch description, and your launch description always has a series of nodes where you define its package and the executable name. To purpose of the slide is just to say launch descriptions can be initialized multiple ways. Is it just these three? No, there's more. I know of a fourth way, and if I know of a fourth way, I'm pretty sure there is a fifth way. Just don't be confused when you see different ways being used. If so far you're looking at all this and say, hey, this is actually a bit easy, I didn't even need a lecture on this, well, good on you, but launch systems can get a bit more complicated. Very quickly get more complicated. If you look at a launch file from an open source ROS2 project, most of the time they will not be as simple as the one we just wrote. There will be event handlers. Maybe specific messages have to be received. Maybe a specific node has to die before another node has to go up. Dynamic reconfiguration refers to changes being made to your node at runtime. Maybe node X is already up and running, and then about half an hour in or a day in, you change your mind and say, hey, actually, I want you to stop doing what you're doing, but I don't want you to stop completely. I want you to change your behavior slightly to this. That's dynamic reconfiguration. Conditionals, similar to event handlers, maybe you want something to happen under specific scenarios. Launch files can have launch files, which is a bit of a headache and can get confusing. And of course, we've only dealt with the node action so far, but there's so many more actions. There's ROS specific actions, then there's non-ROS specific actions. Let's take a look at one now. Launch arguments. What if the nodes we want to launch require some command line arguments? So I said earlier that not only can nodes that start at the same time, we can also specify parameters when we start our node. Launch arguments allow launch files to be configurable through this action called declare launch argument. This one is not ROS specific. It's from the original Python launch module, and it allows the input to the node to be dynamic when the launch file is, well, launched. There's one thing I want to make very clear here. Adding arguments to a node through a launch file is very, very different to setting parameters. ROS2 parameters are its own special topic, which we'll be covering not next lecture, but the lecture after next. Arguments are launch file specific, and parameters are node specific. Is there a preference on which to use? Yes. The preference is to use parameters because they're more tightly coupled with the node, and that's what you want, but we haven't covered it. So we're going to look at how do we add arguments instead, which is similar but not as good as parameters. But that's also why I won't be showing a live example. I'll just be giving you a quick overview of how it works. So if you look at the code snippet at the bottom here, we see declare launch argument. That is an action. What does it take? It takes the name of the argument. You can specify more parameters as well. Common ones are the default value, and in case people don't know what it means, you can provide a description as well. And all you gotta do is when you define your node action, instead of just specifying the package and executable, you also pass in this argument, and you append that to your launch description. We'll see that in just a bit. So recall our publisher. So this is the publisher that was running when I ran in the terminal like 10 minutes ago, and it's the same publisher from the previous lecture. As you can see, there's not much room for configuration. We are always publishing the same XY coordinate. So let's add some ability to configure it a little. If you didn't notice the change, I'm gonna do it one more time. The difference is the float x and the float y in the constructor. So instead of me saying, hey, always send x equals 1, y equals 2, for that example, I can configure it so that when I launch the node, I can specify what the x and y coordinates should be. What does the main function look like? Well, arguments are passed in this scenario as command line arguments through argc and argv. Argc, of course, for how many arguments are being passed, and argv for what the actual arguments are. We're going to take the arguments and then we're simply going to pass it into the constructor of our node when we create it. So we compile the node first, and then during runtime, when we try to run the node, we say, hey, let's use this X and let's use this Y. And that's how we use launch arguments. Once again, I'm just showing this for demonstration purposes. I would prefer use parameters, which will focus on a future lecture. So I hope that makes sense, because now we are moving on to the second part of the lecture. I misspoke. No, we're not moving on to the second part of the lecture. You've seen the code, but now you need to see what the launch file actually looks like. Look at the second line. It says from launch.actions, import declare launch arguments. This is evidence of what I said earlier, which is most of the time you would just be using the node action, but there are other actions, and it doesn't have to be ROS specific. In this case, this is declare launch argument, which is not ROS specific, but it's an action. And it's passed through to the node. If you want to play around with this example, go ahead. In fact, I encourage you to, and try to figure out what's going on. Now we're going to the second part of the lecture. The second part of the lecture is ROS interfaces. I mentioned earlier that you've already been interacting with interfaces, and you may just not have realized, or maybe you already know what it is. What are they? Well, interfaces are the backbone of how nodes communicate with each other. I would say without interfaces, ROS2 loses its specialty or its uniqueness. Without interfaces, ROS2 is not ROS2. There are three main types of interfaces, and they are messages, which we are going to be focusing exclusively in this lecture. There's two more, which are services and actions. These are going to be covered in the same lecture, not the same lecture, but in the same lecture in a future lecture. I think the sixth ROS2 lecture is on services and actions. So as you may be aware by now, messages are how publishers and subscribers communicate. Right? In that publisher-subscriber example from earlier, my publisher is sending messages to the subscriber. Oh, I went a bit faster. Services. What are services? Services represent a client-server relationship between two nodes. Your first node could be a client and say, hey, I have a request. And it will take that request and send it to another node, which acts as a server. The server takes in the request, does some computation, whatever it needs to do, and then it will send the response back to the client. Actions are very similar as well, but they tend to be a lot more time consuming than services. Services are usually fast. You want them to be as lightweight as possible, but actions can take a long time, and because they can take a long time, there may be some intermediary feedback in between, and that's the difference between services and actions. We'll go more into detail in a future lecture, as I mentioned, but for now, we're going to focus exclusively on messages. Each interface have their own IDL. If you see ROS IDL, it stands for ROS Interface Definition Language, and the interface definition language is how these interfaces data are defined. So these are the data structures for these interfaces. They're basically files, .msg files, .srv files, or .action files for messages, services, and actions respectively. So let's take a closer look at messages. Messages are the most common way to communicate between two different nodes, and each message, if you have noticed so far, has not only a message type, but a message package that it belongs to. An example would be sensor messages / laser scan. This is the message that comes from your Turtlebot's LiDAR. The message type is a laser scan because, well, obviously the LiDAR is a laser scanner, and the package that it belongs to is sensor messages because a LiDAR is a sensor. And these are built into ROS2, of course. They come with these messages. And there are different types of packages for different types of messages. Standard messages are one of the most common ones. These are integers, floats, strings, booleans, sensor messages as we just saw. For sensors, most of the common sensors in the robotic world are already built, messages for them are already built into ROS2. So laser scan are for 2D lidars. There's also messages built in for IMUs. I should probably make this capital case here. Inertial measurement unit, I hope you guys all know. Cameras, most sensors, the messages already defined for by ROS2. There's geometry messages for poses, points, orientations, and there's nav messages for anything to do with navigation, such as maps or odometry. Is that all? No, there's many more. Again, I don't remember at the top of my head, but there's more. And you can check it, as always, in the official ROS2 documentation. So why ROS messages? What makes them so special? Let's think about the languages that ROS2 supports. We know that it officially supports Python and C++. We're only focusing on C++. But there's also bindings for other languages that are not officially supported, but they still kind of work, like Java, JavaScript, and Rust. I believe there's more, I'm sure. When defining these messages, we don't want to define something for Python, then define it again for C++, then define it again for Rust. No, we want the messages to work across all languages. So we want to define messages once, and we let the compiler translate. And that's why we use ROS messages, because, well, it does exactly that. How does it do that? Because it automatically generates the functionality for you, and what makes it special is it takes care of all the templating that's required. So you guys have covered templating earlier in the course, which is where using ankle braces, looks like this, you put in the data type that's needed, like integers or even another class. In this case, let's say a message. This message is at the very core are just structs. If we create a publisher, usually we've been putting what message type it is, right? Let's say we create a custom message. We'll come back to that in a bit. The templating, the under the hood nitty-gritty that's required to write up all the code that's required, the IDEO takes care of it for you, so that you don't have to worry all about that. And that's why ROS messages are helpful, as opposed to doing something outside the box. And of course, there's things like serialization, making sure the messages are being sent properly, and shared pointer functionality, because everything in ROS2, if you've noticed by now, is a shared pointer. And just having common messages simplifies integrating with anything, really. If you have two different lighters, and then they're like sending messages that are not the same, like let's say one's a proper ROS2 laser scan message, but one is its own custom thing, that just makes life harder for you. You don't want that. So if everyone uses ROS messages, it simplifies a lot of integrations. And of course, you can look at the message definitions as well. So for example, I can do ROS2 interface show. What would we do? Let's use sensor messages. Interface show sensor messages, message, and laser scan. As you can see, it works. Here's the laser scan message. We'll look at it in just a bit. But let's just look at a few messages that are common in the robotics world from different packages. One, twist. By now, I hope you all have played around with your turtlebots, making it go around using teleop. While you're teleoping, if you do a ROS2 topic list, you should see the topic command velocity. If you do ROS2 topic info onto command velocity, you should see that it's a topic where twist messages are being published. What is a twist message? It is for velocity, both linear and angular. And because it's two components, linear and angular, you can see that the messages are broken down into two vector 3D messages. This is a good point this is a good stage for me to bring up that messages can be built up of other messages. So we have the twist made up of vector messages, and then a vector message can be broken down into just 3 simple floats, each representing x, y, and z. So when you're sending speed commands to your turtlebots, what you're actually doing is sending twist messages. Sensor messages for laser scan. It's like the third time we spoke about it. But things like, hey, what time did my message come in? What is the minimum angle increment that I can use? What is the current angle increment that I'm using? How long did it take to scan my surroundings? What's the max range that this laser can handle? And what are the ranges I actually detected? This a very common message you'll be using in the course. Let's look at final one, odometry. Odometry send pose messages. Pose, once again, are made up of 2 components. You have point for position, X, Y, Z. And in a map, whether it's 2D or 3D, where is it? Give me the coordinate. And then orientation is also involved, because just because it's here doesn't mean you know exactly how it's oriented. Is it oriented like this, or like this, right? It's just a matter of the rotations involved. So those are 3 common messages in robotics. And to bring it all to a circle, to come to a close, let's summarize a few key findings. ROS2 messages can contain primitive types and other messages. So primitive types refer to things like integers, unsigned integers, floats and decimals, strings, time, variable length dynamic arrays. Under the hood, these will be implemented as vectors in C++. Then there's fixed size arrays, and don't forget other messages. Just like we saw with the twist message, it was made up of vector messages. What if with these messages there are some constants that you need to define? Just like any classes or code you may write, sometimes there may be constants that you need to define. All you need to do is use an equal signs and define what it should be. So for example, let's say we're looking through a message, we see float 64 latitude, expected, but then let's say you have a covariance type, and you want that value to always be the same. You simply define it like you usually do and say, hey, let's make this equal to whatever that constant value should be. I hope that makes sense. So to go to the final part of the lecture, and our final hands-on part as well, custom messages. I hinted it a bit earlier when I mentioned that we could create a publisher with a custom message. Basically, let's just fly through this. What if the messages from ROS2 just isn't enough for you? You may have an application where you go, hey, I have all these interfaces, but none of them simply fit what I need for my task. I need to create a new type of message. Is that possible? The answer is yes, of course it is, because ROS2 has a lot of what's the word? Flexibility? That's not the word. Configurability. That might also not be the word. I'm not sure. There's a word for that somewhere. You can create your own custom messages, and not only that, you can create custom interfaces. So sneak peek in the future, you can also create custom services and actions. Custom interfaces can be defined in their own respective folders. So in our cases, because we're focusing on messages, they're going to go into the message folder. If you recall, in our package, we do not have a message folder. We have a launch folder that we just created, but we do not have a message folder. So let's just create one now. It's empty, of course. And then we can create a custom message as well. Let's say custom message.msg. It's going to be empty, so let's fill that out. Let's say there's going to be a float. That's not how you spell it. Another float, and then usually you would have another float for Z, but because it's custom, let's go crazy and add a string. I'm going to call it message. So we have our message there now. And I want to show you something before I go to the next line on the slide. Before I go to the next line on the slides. Okay, sorry, that was a cut there. For whatever reason, my terminal command from earlier shut down my computer. So what was I saying? Where were we? Yes. So what I was saying was, let's have a look. I want to show you something. This was the command. It was not this command that shut my computer down. Instead of pressing backspace, I pressed the power button. Anyways, if you look in the install folder of your root workspace in ROS2, you should see your package there. And if you list out the contents of your package, you see there's lib and share. Lib usually contains your executables. So if you go inside lib, you see that you have your executables. These are the executables that run whenever I do a ROS2 run simple publisher. So if I do / simple publisher, that's where my node start. That's because that's the executable. I just want to show you that's where it is. That was not the point. The point was we have that lib and share folder. And why do I say this? Well, you'll see that in just a sec. Let's go to this next line. The ROS IDO that I mentioned earlier, it's going to pass the custom message file that we just defined. Our message here, x, y, and message. It's gonna make sure there's no like syntactical errors or anything. And if it succeeds, it's going to create a bunch of code that's automatic. It's gonna automatically generate code that does the templating magic that we spoke about earlier. And the relevant headers can be found here. But this file path doesn't exist from what I saw earlier, so we gotta Cocon build it first. Of course, the custom message we're gonna use is XY string that we just looked at, and of course there's documentation that you should be reading every time. So ROS2 messages, here's the documentation. The first link here is actually from ROS1, but messages haven't really changed between ROS1 and ROS2, so it's still safe to read that, just letting you know. Messages are defined in the message directory. We've established that. But the main part here is that message, if it's passed successfully by the ROS IDO, it should create a bunch of header files. Let's look at that happening. And to do that, we need to tell our package.xml and cmakelist that we have a new directory. So similar to our launching example from earlier, because CMake is the builder of our workspace, because we're using C++, it needs to be aware of all the files that are there. When we created this new launch folder, CMake didn't know about it. Just because we create something doesn't mean CMake knew about it. We had to tell CMake, hey, we've created this new launch file. Remember this? We had to add that. So we have to do the same thing with custom messages as well. So if we go to ROS2 custom interfaces, there are some specific lines you have to put in the CMake list. Let's have a look. Should be here somewhere, I think. Okay, here. It says you have to open your package.xml and paste these lines. So it's not just CMake list you have to modify, but you also have to modify package.xml, because your package.xml defines your dependencies. So for example, RCOCPP is a dependency, geometry message is a dependency, but the ROS IDO is also a dependency. Gonna format this nicely. So I'm gonna do that. I'm gonna come back, and then it says ROS IDO generate interfaces. I'm gonna put that line in, and I'm gonna put it here. So the way this works, I just did this very quickly, is you have to explicitly define here what your custom interface is. Because we have a custom message, we put MSG, and our custom message name is very creatively custom message.msg. So I've put that here. If it was named something else, I would put something else here. And if it was an action, I would do this instead. Hope that makes sense. So that should be it in terms of making our package.xml and CMake list aware of the changes. Let's see what happens now when we Qualcomm build. It's taking a while, so I think it's doing its job. So let's go back to the install directory from earlier. Go to our package, and if you look now, there is a new folder called include. Let's go inside include, go inside of the package again. There is a new message folder. That seems promising. Let's go inside there. And we see that there's now a new header file called custommessage.hpp. If we try to look at what's in there, we see that it includes a bunch of more stuff. Let's just look at one of them. If we would look at the struct header file, here's the struct that was generated. It matches our custom message, as we see here. There's an X, there's a Y, and there's a string. Right? So when I said earlier it generates all the templating magic that's required, this is what it's doing. There's a bunch of files that's being created. So let's see it in action. Our publisher was previously sending poses from geometry messages. I'm going to copy paste all of this into a new file that I'm going to call simple publisher custom.cpp. Paste that in. We don't have geometry messages anymore. Instead of geometry messages, what we're going to do is put in our custom message. The way it works is define the package. The package that we've defined our custom message in is this package, which is mtrx3760. And it's a message. And instead of pose, it's going to be custom message. That means all of this needs to change as well. Instead of geometry messages, message post, it's going to be mtrx3760 message custom message. There we go. VS Code is already telling me there's a few errors here because my message doesn't have position or orientation. It just has XY. So can I get rid of position there? Can I get rid of position there? And the error went away. We also don't have orientation. What do we have instead? We have a string. What did I name my string? Message. Oh, shit. I should have been more creative there. Message is equal to hello there. And I'm going to change this to 3 and 4. Sending post XY message. Once again, we need to get rid of the position. And then I'm going to add in our message, but make it into a C style string. I don't think I've missed anything. Let's see how it goes. No, I have missed something. But it's actually good that I remembered. Because let's see what happens if I just try to build this. Okay, I missed two things. I have to tell CMakeList that that there's a new file. I'm gonna do that. This is not the big thing I missed earlier. This is another thing that I missed. I'm gonna call it simple publisher custom. Okay, let's try Cocon building again. I'm still missing something. That's what I missed. So there's an error. It says, hey, your message cannot be found. But that doesn't make sense, right? Because we saw that we've already generated the header files. It's not like when I try to build, the header files are gone. Header file still there. So what's going on? Why do we have errors? Why do we have a cannot find this message error? Well, the answer is it has to do with the way packages work. We have defined this custom message in the same package as everything else. And by everything else, I mean these publishers and subscribers. And everything else I'm going to add for the rest of the course. I mentioned earlier that there should be a separate package, but because it's in our own package, things can get a little confusing. Because it's in our own package and we need things to be compiled and for our package to know everything that we need, our package becomes a dependency to our package, if that makes sense. It's confusing, but we now have to say this part of CMakeList here, this is saying this is stating all the required dependencies. Our package becomes a dependency because our package generates this custom message that we need, as confusing as that may be. So we gotta do find package mtrx3760 required. And then when we come to building the executable, instead of geometry messages, we don't need that anymore. We have to put mtrx3760, this package that we're in, as a dependency because it's this package that has the message that we need. Now let's try Cocon building again. And hopefully this time it works. Otherwise, I'm just going to be embarrassing myself. Fingers crossed. There we go. Now let's try doing ROS2 run, mtrx3760, simple publisher custom. Look at that. We're sending a custom message which has x as 3, y as 4, and then a message hello there. We can debug it now. So if you do ROS2 node list, we see, sorry, not node list, we do ROS2 topic list, we see flight / waypoints as our topic, and if we do ROS2 topic info on that topic, we see that the message is our custom message type. There's one publisher, no one's subscribing to it. That's a bit sad, but you can write a subscriber to subscribe to this. Try it out. It should work. I encourage you to try it out. And that means we can also do ROS2 interface show mtrx3760 custom message, and it shows our xy string, our float string xy message. You get what I mean. Let's go back to the slides. It's been a while. Is there anything left? Need to tell package.xml CMakeList their messages. We've done that. It's common to have a separate package for messages. This is what I was getting before. We did not do that, but it is common to have a separate package. Why? because the main thing here is it reduces inter-package dependencies. If you require a custom message, there's a chance that later on you may need it again in a separate application. And when that is the case, you want just the messages to be brought in. You don't want everything else that your package may have to be built as well. You may not want to bring everything else in. And yeah, building messages independently, separating the interfaces, those are all important. But that last point there of inter-package dependencies being reduced is the main thing in my opinion. This is the code that I just wrote. I encourage you to try out what the subscriber should look like and play around. And that brings us to a wrap. How long was that? It was under an hour. That's good. So we covered the launch system. We found out what launch files are. We found out the details about what launch files are, such as the launch descriptions, actions, what it should return, the functions that are required. Then we saw how launch files could get more complicated. We look at one specific example, which is adding arguments. Once again, I wouldn't look too close at that example. There's a ROS2 parameters lectures that's coming later on, which does a very similar thing that should be more preferred. Then we looked at interfaces with a specific focus on messages. We looked at common messages that we may encounter, not just in this course, but also in just the general world of robotics. And then we asked the question, what happens when the ROS2 messages that are built in just isn't enough for my application? One very important thing I didn't state when we were talking about custom messages is think twice before you start defining custom messages. Most of the time, if you feel like you need a custom message, you probably don't need a custom message, or you may just have designed something badly. So there'll be rare instances where you need custom messages. But if you do, now you do. Now you know how to use them and build them. That's a wrap. Hope that makes sense. As always, if there's any questions, please feel free to ask on Ed. Thank you.